Hey everyone, welcome. Have you ever really thought about what's inside all the stuff we use every single day? I mean, really thought about it? Well, today we're going to pull back the curtain and uncover this hidden world of minerals and energy. It's the stuff that makes everything from your phone to, yes, your toothpaste, even possible. So let's dive right in. All right, so let's start with a little riddle for you. What do your toothpaste, the phone you're probably holding right now, and your car all have in common? I mean, on the surface, they seem totally unrelated, right? Well, the answer, it's actually pretty wild. They are all, one way or another, products of the Earth's crust. Every single one is made from minerals and brought to life by energy.
Rocks in your toothpaste? Yeah, you heard me right. It sounds kind of strange, I know, but that's exactly where we're going to start our little journey today, with something you almost definitely used this morning. We are going to break down the surprising and, well, frankly, the rocky ingredients in your toothpaste.
Okay, so just picture your toothpaste for a second. It looks like a simple paste, right? But in reality, it's basically a very carefully designed collection of rocks. You know that gritty feeling that cleans your teeth? That's silica and limestone. The stuff that fights cavities, fluoride, that comes from a mineral called fluorite. And that super bright white color? Titanium oxide. Oh, and if your toothpaste has that little sparkle, you can thank tiny flakes of mica for that. And get this, the plastic tube and even the brush, they come from petroleum. It's literally a product of geology from start to finish. You know, this reminds me of a story I read about a young boy named Haban. He's from this super remote village, and he goes to a big city for the first time and is just completely blown away. He sees buses and trains and thinks they're moving houses. He asks his dad, hey, why don't our houses move? And his father has to explain that no, these aren't houses made of brick and stone, they're vehicles made of metals like iron and aluminum, and they run on engines that need energy. Haban's total amazement is such a great reminder of how easy it is for us to just take this whole world of minerals and energy for granted, because we're just so used to it. And look, this isn't just about toothpaste or buses. It goes so much deeper than that. I mean, just look around you right now, wherever you are. The same principle applies to pretty much everything. These minerals, they are the absolute fundamental building blocks of our entire modern world. And when I say everything, I mean literally everything. From the tiniest little pin holding your clothes together to a massive skyscraper scraping the sky. The ships crossing the ocean, the trains on their tracks, our tools, our machines, even the food we eat has minerals our bodies need to function. Humanity has been using minerals for, well, forever. For survival, for building things, for art, for everything.
So what even is a mineral, really? What's the official definition? Well, geologists have a very specific one. It's a homogeneous, naturally occurring substance with a definable internal structure. Okay, let's break that down real quick. Homogeneous just means it's the same stuff all the way through. Naturally occurring, pretty obvious, right? We don't make it, the Earth does. And definable internal structure means its atoms are lined up in this perfect repeating pattern. And that pattern is what gives us everything from the softest talc powder to the hardest diamond you can imagine.
Okay, check out this story. It's a perfect example of how our whole view of minerals can just completely flip over time. Back in the 19th century, the Emperor of France, Napoleon III, would serve his most important, most honored guests on aluminum utensils. Yeah, aluminum. Why? Because back then, it was insanely hard to get, which made it more valuable than gold or silver. So the VIPs got aluminum, while the, less important guests had to settle for plain old gold. Can you imagine? Then, just 30 years later, technology changes, aluminum becomes cheap and common, and it's being used for everyday stuff. A mineral's value isn't fixed. It's all about our technology.
So, these materials are incredible, right? But here's the thing. Our complete dependence on them, well, it comes with a really serious flip side. We've talked about what minerals do for us. Now, we have to ask, what does it cost to get them? Because the process of pulling these things out of the ground has a very real and often a very high price.
So where does all this stuff actually come from? And what's the true price we pay to have it? We know we need it for basically everything, but the journey these minerals take from deep inside the earth to our hands, it is not clean, and it is definitely not simple. It involves a ton of effort, huge risks, and some really serious consequences for people and for the planet.
And if you want to really understand the human cost, look no further than this incredibly stark example from parts of northeast India. It's a practice known as rat hole mining. It's where family members literally dig these long, narrow, terrifyingly small tunnels deep into the earth just to pull out chunks of coal. It's an unbelievably dangerous practice. It's been declared illegal now, thankfully, but it just gives you this powerful, hunting picture of the extreme lengths people go to and the dangers they face to get these resources.
The dangers of mining are really, really severe, and they basically hit on two separate fronts. First, there's the direct danger to the miners themselves. You've got constant dust and toxic fumes that lead to awful lung diseases, not to mention the constant threat of a tunnel collapsing or floods or fires. Then, second, you have the massive environmental toll. Mining just scars the landscape. And all the chemical waste, they call it slurry, it leaks into the water, contaminating streams and rivers and poisoning entire ecosystems.
Okay, but now think about this for a second. Getting those minerals out of the ground, that's just step one. Turning that raw ore into something we can actually use, like metal, takes an absolutely insane amount of energy. And that brings us to the other half of our story, the energy that powers this entire global machine. Yeah, you really can't separate minerals from energy. They're basically two sides of the exact same coin. You just can't get one without using a huge amount of the other. Think about it. Mining iron ore, hauling it, smelting it into steel, all of that requires massive inputs of energy. Our hunger for minerals is directly fueling our hunger for power. And when it comes to getting that power, we are really at a major crossroads. For centuries, we've relied on what we call conventional sources. You know them, the fossil fuels, coal, petroleum, natural gas. They powered the Industrial Revolution for sure, but they're finite, meaning they will run out, and burning them is a huge source of pollution. The other path is the non-conventional sources. Solar, wind, geothermal, you name it. These are renewable. They don't run out, and they are way cleaner for the environment. And if you really want to get why we call them non-renewable, just think about how they're made. Let's take coal. It's the result of a geological process that takes millions of years. It starts with tons and tons of plant matter in ancient swamps. Over eons, that stuff gets buried deeper and deeper under layers of dirt and rock. All that heat and pressure from the earth basically cooks it and squeezes it, eventually turning it into the coal we burn today. Nature took hundreds of millions of years to make this stuff. We're on pace to burn through it in just a couple of centuries. It's kind of mind-boggling.
And that brings us right up to today. We're kind of facing a perfect storm, really. The price of fossil fuels keeps going up as they get harder to find, and at the same time, we just can't ignore the environmental damage they're causing anymore. So this combination of economic pressure and ecological reality means we really have to speed up the shift to cleaner, renewable energy.
So, what do we do? It's a tough spot, right? We're completely dependent on all these resources, but getting them is costly, and we know they're not going to last forever. But look, this final section isn't about doom and gloom. It's about smart solutions. It's about the path forward. It's about a whole new way of thinking.
Just look at this number, 1%. What is that? Well, that is the total volume of all the mineral deposits on the entire planet that we can actually reach and use. Just 1% of the Earth's crust. It is a really stark reminder that the stuff we have is incredibly precious and incredibly rare. And this right here is the core of our challenge. The processes in the Earth that create these minerals are just unbelievably slow, but our rate of using them up, it's breathtakingly fast. I mean, for all practical purposes, they don't get replenished. The mineral deposits we have are so valuable, but they are also finite. They are short-lived possessions. So tackling this requires a serious combined effort on a bunch of different fronts. First, we've got to adopt smarter, more sustainable ways of mining that do way less damage. We also have to get really serious about recycling. Reusing the metals we've already pulled out of the ground is just so much more efficient than digging up new ones. And we've got to keep innovating, developing new technology that lets us use lower-grade ores that we used to just throw away as waste.
But listen, this isn't just on big companies or governments. We, as individuals, as concerned citizens, have a huge role to play here. Simple choices, when a lot of us make them, they have a massive impact. Choosing public transport over driving alone saves a ton of fuel. Just being mindful about electricity, flipping off lights, using power-saving devices, that directly lowers the demand on our power plants. And we can all push for the bigger shift by supporting and using non-conventional energy sources in our own communities and our homes.
And that leaves us with this one last really powerful idea. And if there's one thought I want you to take away from all this, it's this. Energy saved is energy produced. It sounds simple, but it completely changes how you think about conservation, right? Every single watt of electricity you don't use, every drop of fuel you don't burn, that is just as valuable as generating a new watt or finding a new drop. It's the one energy resource we can all create right now, just by being a little more mindful. And really, that's the first and most important step to securing our future.